Alright, so in this video, I'm going to be solving the problem 2 to the power of 20 minus 1. So I want to find the value of 2 to the power of 20 minus 1. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2 is equal to 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 I can rewrite as 1 squared because 1 is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 squared. And the reason I put this in this form is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10 and b is equal to 1. So now I get 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now 2 to the power of 10 is equal to 2 to the power of 5 plus 5, which is equal to 2 to the power of 5 times 2 to the power of 5, which is equal to 32 times 32, and 32 times 32 is 1024. So I get 1024 plus 1 times 1024 minus 1. Now 1024 plus 1 is 1025, and 1024 minus 1 is 1023. So now I have 1025 times 1023, and to solve this, or to multiply these two, I'm not just going to do it using the basic multiplication method because this takes way too long. Instead, what I'm going to do is I'm going to rewrite this as 1000 plus 25 times 1000 plus 23, and now I can distribute my 1000, so I get 1000 squared plus 23 times 1000, and now I can distribute 25, so I get 25 times 1000 plus 25 times 23. Now 1000 squared is equal to 1 million, so I have 1 million plus 23,000 plus 25,000 plus 25 times 23, which is 575. So now from here, 23,000 plus 25,000 is 48,000, and 48,000 plus 575 is 48,575, and that plus 1 million is 1,048,575. So this is my answer to this problem. Alright, so in this equation, I have x to the power of 4 plus x squared is equal to 20. So to solve this, what I'm going to do is first start by subtracting 20 on both sides, so we can have all our terms on one side. So I get x to the power of 4 plus x squared minus 20 is equal to 0. Now this may seem like a quadratic equation, but it's not because we have the power of 4 as our primary term, and then that's led by the power of 2. And in a normal quadratic equation, we have 2 as our primary, then we just have 1, and then we have some constant c. So how are we going to solve this? Well, we can't factor this out by using the quadratic formula because this is not a quadratic equation. So to solve this, what I'm going to do is rewrite this as x to the power 4 plus x squared minus 16 plus 4. So I rewrote 20 as 16 plus 4. And the reason I did this is because negative 16 is the same thing as negative 2 to the power 4, and negative 4 is the same thing as negative 2 squared. So now notice how I have something in the power of 4 and something in the power of 2, and they're both the same. Now I can put the powers of 4s together and the powers of 2 together. So I get x to the power 4 minus 2 to the power 4 plus x squared minus 2 squared is equal to 0. Now 2 to the power 4 is 16, and 16 is the same thing as 4 squared as well. So I get x to the power 4 minus 4 squared. And I have this plus x squared minus 2 squared. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 is the same thing as x to the power of 2 times 2, which is equal to x to the power of 2 to the power of 2. So now I get x to the power of 2 to the power of 2 minus 4 to the power of 2 plus x squared minus 2 squared is equal to 0. Now notice how everything is in the power of 2, and if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So we're going to use this property on these two groups. So I first get x squared plus 4 times x squared minus 4 plus x plus 2 times x minus 2 is equal to 0. Now we can use this property again on x squared minus 4 by rewriting as x squared minus 2 squared. So that's going to equal x plus 2 times x minus 2. And I have this plus x plus 2 times x minus 2 is equal to 0. Now I'm going to factor out x minus 2, so I get x minus 2 times x squared plus 4 times x plus 2 plus x plus 2, which is equal to 0. And notice how we can also factor out x plus 2 as well. So actually at the start what we could have done is just factored x squared minus 4 out, but now we're going to factor out x plus 2 as well. So I get x plus 2 times x minus 2 times x squared plus 4 plus 1 is equal to 0. So x plus 2 times x minus 2, like I said, was x squared minus 4. And I have this times x squared plus 4 plus 1, which is x squared plus 5. Now this is equal to 0. Now this gives me two equations. I get x squared minus 4 is equal to 0, and I get x squared plus 5 is equal to 0. So for x squared minus 4 equals 0, I can add 4 on both sides. So I get x squared is equal to 4, and this is equal to positive or negative 2. And for x squared plus 5 is equal to 0, I get x squared is equal to negative 5, and I get x is equal to positive negative square root of negative 5, which is equal to positive negative square root of 5i.